doing problem 50 on page 348, and we're looking at how the amount of ammonia at equilibrium will be affected by several different factors. So first I've just written out the equation. And so let's look at number 1 on part A. So we're looking at removing oxygen, which means that the reaction is going to shift left, which will increase the amount of ammonia. So, yeah. And then for the second one, adding nitrogen, that will also cause a shift left because we're going to shift away from the nitrogen and shift towards ammonia, which will cause an increase again. Adding water, well, since water is a liquid, as you guys can see, that's going to have no effect because it's a liquid, so it's not a gas. So there's no effect there. And then expanding the container at constant pressure, well, we're going to have to look at here. If this side has 7 moles of gas, and this side only has 2 moles, so that we know that it's going to shift left because it's going to shift towards where there are more moles of gas. So that is going to be an increase in ammonia. And then finally, I'm going to rewrite the equation for number 5 because we're talking about temperature, and they've given us, this delta H here, and it's negative, so we know that it's exothermic, so that heat is going to be here on the product side. So I've rewritten it with heat, which is really helpful when we're talking about temperature. And again, we know that it's going to shift left because you're adding heat by increasing temperature. So that's going to cause an increase in ammonia. So that's all for part A. So I'm just going to get rid of this, and then we're going to talk about part B. So part B is talking about which factors will increase K or decrease K. So none of them will actually increase K because the only thing that can have an effect on K is changing temperature. And we know that number 5 is the only one that involves temperature, and that is not going to increase or decrease, it's not going to increase K because it's going to cause the reaction to shift left, which will make more reactants. And we know that the Kp equation has reactants on the bottom here. So if you have more reactants, then that's going to cause the K to be smaller. So we know that number 5 is going to cause K to decrease. That's all. Thank you.